Hello, Renee Miles here. In this projectile problem, what we're looking for is when something is launched at 25 miles per hour, what's the maximum height it's going to travel? Projectile problems are going to include the vertical column and the horizontal column. I've tried to list out the individual items. The idea is to have all of the vertical information and horizontal information here. The only thing that goes from one column to the other is the time. May not need that. But I think we're mostly interested in the vertical. When a projectile goes up, its horizontal component will always stay the same, but its vertical component won't change. When it reaches its maximum height, it's still moving forward, but its vertical velocity hits zero. Maximum height, the vertical velocity will be zero. So, and we'll go at max v2v equals 0. Really not concerned with the 30 degrees. I'm really concerned with what happens from here up to the top. So I'm going to split this into components here. 200 times sine of 30 which equals 100 meters per second. The initial vertical velocity is 100 meters per second. I've chosen up as positive. If it's up, it's positive. When it gets to the top, it will still be moving sideways, but the vertical component is here. We know that the acceleration here is negative 9.8, and I have 100. So I have 3 of my variables, and I can plug them in, and we can know how high it went. I have A, V1, and V2. My equation will be V2 squared times D2 is 0, D1 100 squared plus 2 times negative 9.8. This is really messy, but I'm solving for D, and I get 510 meters is the height that means that when the projectile goes up and it gets to that height, its vertical velocity is 0. It's going to start to descend. That height that it can go to is 510. That's it. Thank you very much. I hope I covered what we were doing this time. Have a good night.